now we are going to discuss synthetic division. So synthetic division is a process that we can sometimes use to replace the process of long division. Now this process does not work for every single problem. We need special, specific types of problems for this to work. So the synthetic division method only works when your divisor is a linear factor. Hang on, my pen's still trying to get its bearings. There we go. Now my pen's working. So what I was trying to show you is your divisor has to be a linear factor in order for you to use synthetic division. So some examples of this are like x minus 1, x plus 3, anytime that it's a linear factor with just, two terms, okay? So that's a requirement for you to use synthetic division. So as you can see here, we are trying to divide x to the 4th power minus 10x squared minus 2x plus 4 by x plus 3. So if you were to do long division, you would write it out on the inside and the outside. But here is a process called synthetic division. So here's how you set it up. Okay, use this box. This is like a guided synthetic division for the first one. You look at the sign of the number here in this, what you're dividing by, which is x plus 3. What is the opposite sign of positive 3?
Negative 3.
That's what you put here. Now, to know what to write up here, you're going to look at the number you're dividing into, the dividend. Why did you put this number in? Or why did they?
Placeholder.
A placeholder, good. So placeholder terms are when you're skipping. So see how we went from power of 4 to power of 2? Just like with long division, you have to put in a placeholder. Now, once you have the placeholder term in, here's the process. You're going to have this L-shaped, sideways L-shaped bar. You're going to write the coefficients. What's the coefficient of x to the 4th? 1. What's the coefficient of the x cubed?
Oh, 0.
Next one?
Negative 10.
Good.
Negative 2.
Good, and?
4.
4. So here's the process of synthetic division. You bring down the first number. You then multiply the outside number times the number you brought down. What's negative 3 times 1?
Negative 3.
You write that number here. When you do this, you always add. What's 0 plus negative 3? Negative 3. Now you multiply again. Negative 3 times negative 3 is?
Positive 9.
Positive 9. You write it here. Now you combine again. What's negative 10 plus 9?
Negative 1.
Good. Now you multiply again. Here and here. What's negative 3 times negative 1? Good. Now you combine again. What's negative 2 plus 3?
1.
1. Now you multiply again. This times this. What's negative 3 times 1?
Negative 3.
You write it here. You combine again.
1.
1. The last number you get in the process of synthetic division is your remainder. Okay? Now, how do you write the quotient? I'll show you. So, you use these numbers. These represent the constant and the coefficient. The first number directly to the left of the remainder is always your constant. Okay? The number after that is always the coefficient of the x. The number after that is always the coefficient of x squared. And the next number, it just keeps going, is going to be the coefficient of x to the third, which is just x cubed. Okay? So, based on how many terms you end up with here, that determines what this is going to be. Now, here's a hint for you all. See how we have x to the 4th power and we're dividing it by x? That means that the result of the division is always going to start with 1 less power than that. Okay? So 1 less power than the numerator when you divide by just a single x, which is x cubed. Now, Now, how you write the answer out is you write the quotient, which we just came up with, plus the remainder over what you divided by. Now, really, you divided by x plus 3. So, synthetic division is a way of removing all the variables for the process. Another way of doing long division, but it's like a shortcut, okay? Are you all ready to try another one? All right. So we're trying to divide this by this. So we're going to put our L-shaped bar in. So you're going to make a bar like this. And you're going to put a little line here and here, okay? Whatever you're dividing by has to be a linear binomial, which it is. And you're always going to flip the sign of the number, so it's going to be a
-3.
good. Now you're going to check and make sure we don't skip any degree terms here. We have the third, the second, the first, and 0. Did we skip anything? Do we need any placeholders? No. Now we're going to write our coefficients out. Bring it down, multiply, combine, multiply. So you see the process that we're doing here. Bring down, multiply this times this. This gives you that. Combine. Okay. Now you do the process again. Take this number, multiply it by this number here. What's -3 times -3?
9.
That goes here. What's -4 plus 9?
3.
5, right?
5.
Good. Now we take this number and we multiply it by this number. What's -3 times 5?
-15.
What's 15 plus -15?
0.
0. So my remainder is 0, right? What does that mean? What did we learn yesterday what that means? That the result is a, starts with an F, factor, as well as your divisor is also a factor. So, how you write your final answer? 2x squared minus 3x plus 5. Coefficient, or constant, coefficient, coefficient. Just goes up in degree, okay? Now, why don't I have to add my remainder over my divisor for this one? Because it's 0, so it's unnecessary, okay? So what do you think? You starting to get the hang of the process?
Yeah, it is easy.
Wait, so you take the top number and you multiply by the side number, and then you put that number under the top number, and then you add them?
Yes, pretty much. I think that's, if I think you're asking me what you're asking me, yes.
Hard.
I think I got it.
Okay. We're going to do it 4 more times, so if it's still confusing, we still have way more trials. So don't worry.
It's easy, but it's weird. Like, it feels like that shouldn't get you the answer. If
Yeah.
That makes sense.
It's definitely, it's one of those things in math that's like a trick for doing, long division is more intuitive because it's a process that makes sense in the sense, this is a trick that's easier, but it's just different to think about. Alright,
It's easy.
so what you're dividing by, you have to flip the sign of. So since it's a -2, it's going to be a
Positive 2.
good. It's always going to flip when it's in this form, okay? Now we check. Coefficient, 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 coefficient. You've only been learning it for about 7 minutes, so I think we can't have such a strong opinion about it yet. Okay. So this is the setup so far, okay? Is everyone understanding of the setup? We're going to first, you always bring down the first number. That's going to give me a 3 here. Now, you multiply 2 times 3, which is 6. Now, you always, when you go down, you always combine, add. Unlike long division where you subtract. What's -8 plus 6?
-2.
Good. Now, once again, multiply what is 2 times negative 2?
-4.
Now you add. What's 11 plus negative 4?
7.
Good. Multiply again. What's 2 times 7?
14. You get a remainder of 0.
Good. Combine, get a remainder of 0. Make sense? See? It'll come. So, how you write your final answer? The number directly to the left of the remainder is always your constant. The number right after that is always the x coefficient. The number after that is x to 1 power up, which is
3x squared.
3x squared. Do we have to write our remainder over our divisor here?
No.
No, because the remainder is 0. That means that both this as well as the divisor are both what to the original polynomial? Starts with an F. Factors of the original polynomial. Okay? Factors of the original. Make sense? Somebody's painting it. Okay. We ready to try another one?
Wait, I don't got this.
The number what?
Like the number in front of the variable?
That is correct.
Okay.
Alright. So if we want to see if something is a factor of something, we can use long division to do that if the thing that we're looking for a factor of, or the factor, is in the form that we need it to be for synthetic division. So we set up. What's going to go on the outside here? Good. What's going to go on the inside?
1, -16.
Good, and -20. We're going to bring down the 1. We're going to multiply -2 times 1, which is what? Good. We're going to combine, which comes out to be? -8. We're going to multiply. What do we get? Positive 16. What happens when we combine -20 and 16? -4 is known as my what? Good. So my final answer, this is my constant. This is x minus 8. That's my coefficient of x.
Plus 4 over x plus 2. -4 over x plus 2.
That is correct. Very good. So does everyone understand why it doesn't have an x squared here?
Because the end is always with a constant. It always goes from the setting below, so it's going to be an x.
Correct, as far as it goes. Yes, question?
So, you take the, like you take the x from over the original thing, where it's like, depending on if it's like, if it's squared, you take it down a step to normal.
No, it's not that. It's that whatever's down here, the first number directly to the left of the remainder is always the constant. And then each one of these represents 1 degree above that. So this represents the coefficient of x. And had it kept going, this would be the coefficient of x squared, coefficient of x cubed, and so on. But you are correct in the analysis of the fact that if you're dividing x squared, blah, 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 by an x, yes, it will take it down a degree. That is true.
Okay, so you get, so what do the numbers in the bottom then mean? Like, I understand the remainder part, but like.
They represent the coefficients
Okay.
of the actual quotient.
I see.
Okay?
So, and then the one that -8 is the coefficient of the 0x?
Exactly.
Okay.
Exactly. The x to the 0 power.
Yeah.
Yes. So is this x plus 2 a factor of x squared minus 6x minus 20? Why do we know it's not a factor?
Because it's got a remainder.
It has a remainder that is not 0. Okay, that's how you determine that. Alright? So this one here uses b's instead of x's, but the process is identical. So we set up our synthetic division box. What's going to go over here?
-1.
Good. On the inside?
1, -4, 1, and -2.
Very good. Now, having taught this for a while, and I also am currently tutoring it, this is one of the things that I see the most mistakes happen on. So in this case, we haven't encountered too many of these, but missing a placeholder term. So like if we jump from third power to b, we'd have to put in that placeholder term for the x squared, or accidentally putting the wrong sign on this number are usually the common mistakes. So I always say just make sure you're looking out for those things, because you want to work smarter, not harder. You don't have to want to redo this problem like a bunch of times when you're trying to go too quickly. So I'm going to bring down the 1. I'm going to multiply -1 times 1, which is -1. I'm going to combine these, which gives me -5. I'm going to multiply this times this, which gives me 5. Combine gives me 6. Multiply gives me -6. Combine, -8. So is it a factor?
No.
No.
No. So our answer is x squared minus 5x plus 6 plus -8 over x plus 1. Now I always forget, it should have been b instead of x because we were using b. So I'm going to change it. You don't have to, it's up to you. I just forgot we were working with b instead of x. Everyone understand?
Yep.
So once again, we set up our synthetic division bar. What's going to go on the outside?
-8.
The inside?
1,
1,
3, and -3.
Good.
3.
Bring down the 1, multiply, combine, multiply, combine. Is it a factor?
Yes.
Yes.
My answer is?
X minus 5.
So isn't it true that if we multiplied x plus 8 times x minus 5, wouldn't that give me this? Or if we just had factored this, what are factors of -40 that add up to +3? Factors of -40 that add up to +3? It's in front of you guys.
5 and 8.
+8
-5 and 8.
and -5, right?
Yeah.
So see how we basically figured out the same information we've been figuring out a different way? Okay, so that's the first thing I want to kind of draw a connection with. The second thing I want to talk about is evaluating. So synthetic division is not only useful in actually doing division, but it's also useful in evaluation. So I want to show you something here. Let's say you wanted to plug -1 into this polynomial. So we would do -1 to the third power minus 4 times -1 squared plus a -1 minus 2. So I'm plugging -1 into this. -1 to the third power is -1. -1 squared is 1. 1 times -4 is -4. Minus 1 minus 2. -1 minus 4 is -5. Minus 1 minus 2. That's -5 minus 3, which is -8. Where does that look familiar in this problem? It's the what?
Remainder.
It's the remainder. So here's something to think about. When you plug this number in to the function, it will be the same result as the remainder. So for a lot of times where I have to plug into say a polynomial of the 7th degree, instead of actually plugging in, I will instead do synthetic division. The remainder will give me what the value of plugging that in is. So you can also check if something is a factor by plugging that value in to the equation and seeing if it comes out to be 0. Yes?
Which one do you think is easier to do?
Personally, if I'm actually trying to check, I always do synthetic division because I actually find people make less mistakes with it. When you have to do negative numbers to different powers, this is a big time that students make mistakes. So I think synthetic division is easier once you get the hang of it. Now the next thing I will mention about your homework, because a lot of people were asking me, if you have something like this, I don't know, whatever it may be, times this, what does that negative 1 power mean? It means that it's actually in the what? The denominator. Isn't this now division? That's what you're dividing by. So when that problem comes up on the homework, that's what you're going to do. So you have